Hey everyone, welcome back to my channel EduVibe. Today we will doing the forces and fields. We are completing a unit and now we're doing the practice question of the last part of the magnetism. Then we do the diploma question of the whole unit. Then we will complete a unit. So let's do the practice questions of the magnetism question. We have like this question. So this question says the current carrying wire is shown below with the compass placed on the top of the wire. So determine the direction of the compass needle will point when electric current flows through the wire. So question is telling that there is a current carrying wire. So this hole is your current carrying wire which has the battery involved in this. And we have a compass over there. Compass is top of the wire. So on the top of the wire we have some compass and determine the direction of the magnetic field. So this is your compass over there and this is something the conductor will involve. So was that north needle which north needle points. So if this is a compass and you're doing the left hand rule in this, so you can see that magnetic force, your magnetic field goes with your coiled hands like this. Like this is your magnetic field. With this is the magnetic field and you're pointed towards this, your lateral flow. So lateral flow goes like this. So lateral flow goes like this. So what's about the north needle? So what's the north needle reacted to this? So north needle, when that type of thing happens, so north needle goes towards the thing which has that magnetic field over there. So where the magnetic field goes, like a coiled fingers goes, so that's the thing that north pole pointed towards this. So that tells you your direction, not the left hand, because it's the left hand number two. So left hand number two is a different than left hand rule number one. This has that two number. So this means the north pole of the compass, or you can say north needle, is points. Next question says that the electron is traveling with a velocity of 1.8 into 10 raised to power 7 meter per second west. The acceleration of the electron is given to us, which is 1.5 into 10 raised to 18 meter per second square. Out of the page, determine the magnetic field. So basically, we have to find the magnetic field, and this will involve the electron velocity, which will like tell us that this is the question of like when we're doing the Fe is equal to Fm. So if the F net is equal to Fe, so if F net is Ma, that means that Fe is equal to the Ma, which is mass into acceleration. So this Fe is equal to mass into acceleration, Fm is equal to QV magnetic field. So I have to find the magnetic field. Then magnetic field is equal to Ma divided by Q times V. So that B is equal to mass of electron is 9.11 10 raised to minus 31 kgs. Your acceleration is given to us 1.50 10 raised to 18 meter per second squared. Divide this by elementary charge of Q because 1 is 1e. So 1.6 into 10 raised to minus 19 coulombs. V is your velocity given to us, which is 1.88 into 10 raised to power 7 meter per second. When you calculate this out, you get magnetic field of about 0.454 Tesla. So this is your answer. Why this is not? Because if you're making the diagram of this, like this is your velocity going to the west. So this magnetic field goes like this if you do the left hand rule, and acceleration is out of the page and Fm is over there. So magnetic field is going to the north when we're doing the case of the left hand rule. So that means north. Next question. The proton is accelerated from rest. So we have a proton and this is at rest and they then accelerated through the potential difference of 40.0 kilovolt and enters the 0.580 meter Tesla. No, this is only Tesla. So Tesla magnetic field directed out of the page. So that's the thing we have over there, and we have to find does the charge moves clockwise or counterclockwise. in the magnetic field, or determine the radius of curvature of the proton in the magnetic field. So first question we have to answer first, that is the how does the charge move, clockwise or the counterclockwise? If this goes over there, it goes to the plate with a magnetic field of this. In that particular case, they will go to the some direction of circular motion, and they have some radius over there which I have to find in second part. But when it goes from here to here, like this to this. Let it follow this path. So it goes to the clockwise direction, and so this means the magnetic force uh, moves clockwise. So this goes to the clockwise direction, and we have the radius of this. And for the B part, we have to find the radius of curvature, and this has a circular motion involved in this, which is Fc, and we also have the magnetic field, which is Fm. So this both are equal to each other. We have mv square upon r, which is equal to the qvb. So from here, 1v cancel out with 1b, and we will find r, and r is equal to mv divided by q magnetic field. We have a mass, we have a q, we have magnetic field. We want to find the radius, but we can't have that v in this. That v should be find out first, then we are going to put the thing in, and that's the answer. So for this v, we have one formula we know, that which is eka plus epa is equal to ekb plus epb. So this is the formula we will know. So firstly, they said that this is at rest, they're starting from the rest, so this means that ek goes to 0 in that case. Also, at the end, that EPB is also goes to 0, because potentiation is ended at the end of this path. Basically, over there, our VB is equal to 0. So that's the thing. From here, if we arrange that formula, if we write the formula in, so we have QVA is equal to half MVB square. Yeah. So this is the formula, and we have to find that VB, that speed. So VB is equal to QQVA divided by the mass and this whole root. So 2Q is your elementary charge, and VA is your, this is the kilovolts, and you have to divide this. So 4.0 divided by 1000 to that in the volt, which you get the 40,000. You get the 40,000 volt divided by the mass of the mass of the proton, which is 1.67 into 10 raised to power minus 27 kgs, and this whole to the power like this. So from here, your VB you find about 2.769 into 10 raised to power 6 meter. This is a non-rounded value, we have to use that value. So we put that V in this. So mass of the proton is again 1.67 10 raised to minus 27 kgs. You find 2.769 into 10 raised to power 6 meter per second of speed, which is divided by the Q. Q is elementary charge, and proton also have like 1e positive. So this means this is elementary charge, and B we also have, which is 0.580. That's one. So from here, when you find, you get the radius of 0.4882 repeating in meters. So we get 0.0498 meters. So this is the answer. This is the rate of curvature we have to find. So you all know that this is like that type of steps you have to follow when you solving this type of questions. And you mostly that the one question of like this one, like how much direction they have, and second one has the calculation one. That question you get like in 3 to 4 months, and sometimes diagram is given to us, sometimes not, but most of the cases you have that diagram in your question. So that's all thing you have to do. So in next question says the electron enters in between the two parallel plates with the speed of 7.8 10 versus meter per second. So we have this electron, a magnetic field directed into the page also between the plates. The length of the place is 20.0 centimeter and the separation distance is 10.0 centimeters. The strength of electric field is given to us 1.5 into 10 raised to power 6 Newton coulombs, and the strength of the magnetic field is 0.1924 Tesla. We have to determine the potential difference between the place and the magnitude of the vertical displacement centimeters of the electron just after it is the region between the plates. So this is a long kind of portion. We have two parts in this. So first part is very easy. We have to find the potential difference. So for first part, we know electric field is equal to delta V upon delta D. We have to find delta V. So delta V is equal to electric field times delta D. Electric field is given to us, which is 1.5 into 10 raised to power 6 Newton coulombs. Delta D is your this one. This is in centimeters, but we want in meters, so the units are in meters. So we convert this in meters and we get about meters. So your delta V is about 1.50 in 10 raised to power 5 volt. So this is your first part, and we answered that. Second part. So as you all know that for this second part, we have to find the two things. We have to find the Fe and the Fm, because the electric field and the magnetic force both are involved in this. So both forces are there, and we'll find the both forces and which force is greater. So that's how we can find that which direction it goes upwards or it goes out downwards. It depends on that thing which you have to now follow. So for this B part, we have to find the Fe first. So Fe is equal to Q times electric field. So Fe, Q of the electron is 1.6 into 10 raised to minus 19 coulombs. And the E for this, we have 1.5 into 10 raised to power 6 Newton coulombs. So from here, we will find the Fe of about 2.40 to 10 raised to power minus 13 newtons. For Fm, we all know that, which is QV magnetic field. So Fm, Q is your elementary charge, and your what is V. So V is given to us, which is 7.80. So 7.80 into 10 raised to power 6 meter per second, and your magnetic field is in Tesla. This one 0.1924 Tesla. When you multiply this whole thing, you get about 2.401152 into 10 raised to power minus 13 newtons. So both in were fine, and which is the greatest one? So it's a greater. So Fm is greater than Fe. So what does this mean? That if Fm is greater, so this means Fe goes down up, which is electric field, and magnetic field goes down, which is the Fm. So we get positive as down, we get down as positive, which is downwards. So basically, what's happened? This whole thing, this electron goes towards this. So that's the main thing. And we have to find now vertical displacement. Vertical displacement means we have to find the dy. So let the dy we have to find. Let's find the dy now. So for the dy, we want something. So basically we want the net force first. Why we have net force? I will tell you why. Because we know that for dy, to find it a dy, so dy is equal to viy delta t plus half ay a delta t square. So that this goes off because they're always 0. And for this equation, we want the acceleration at the time. So both should be fine before we're doing this. For acceleration, we use the net, we finding the first net force, which is equal to Fm plus the Fe. So net force is equal to Fm is about 2.4011, and we take this as positive. So this remains positive. Other one we have to take negative. So which is this one. We find over there. This we already find. So after this, the net force we find is about 1.152 into 10 raised to power minus 16 newtons. After this, you know that net force is equal to mass into acceleration, and we have to find the acceleration. So the net force is divided by the mass. Net force is equal to 1.152 into 10 raised to minus 16 newtons. Mass is the of electron, which is 9.11 into 10 minus 31 kgs. From here, your acceleration is equal to 1.2645 into 10 raised to power 14 meter per second square. So this acceleration you have to use in that equation. So half acceleration is 1.20 into 10 raised to power 14 meter per second. So this is repeating. And now we have to find delta t. So delta t or time. So we know delta t is equal to delta dx upon vx, because we have a velocity of vx and we have a delta dx. Delta dx is this. This whole thing is your delta ds. Because of this, we have the time, and time for delta ds for delta dy stays the same. For both sides stays always the same. So with the help of this, we can find the t. So delta t is equal to delta ds is in centimeters. So 20.0 centimeter, which is 0.200 meters, and your vs is 7.80 10 raised to power 6 meter per second, and you get your delta t of 2.5641 into 10 raised to power minus 8 seconds. Now this has to be put in this now. So 2.5 sets repeating into 10 raised to power minus 8 seconds, and when you solve this whole thing, you get about 0.0145695 repeating meter. Delta dy is equal to about 4.16 centimeters, because we want this thing centimeters. So we again doing the multiply by this by 100 to that's in centimeters. So this is your vertical displacement. You have to, that's all what you have to show. So you get like 4 marks or the 5 marks for this question if you do every work by organized and by the correct way. Most probably you have to always show this direction, that this goes like this when you doing the FE and FM thing. So that's all thing we have to do. So that's all the practice questions we have to cover with the magnetism. Now we're doing a diploma question in next lesson for the whole lesson, that will cap all the lesson now, and this will help you to like ready for the diplomas. So let me say where EduVibe learns smarter but not harder. Please like, share, and subscribe to my channel. If you have any questions, let me in the comment section. See you in the next lesson. Till then, stay connected with EduVibe.